Hello, my name is Bhargavayu. This is my final presentation on my GANs project for deep learning, fundamentals for deep learning. Okay, so this is information about my GANs paper. My GANs paper is about creating an adversarial neural network that uses two neural networks, a generator, the discriminator. The generator generates sample data that mimics what it is trained on, and the discriminator determines whether the data is fake or real. These two networks compete to improve the quality of the generator. And I've attached my paper that I'm going to use to reproduce this to the slide, and as well as I'm going to be creating again and comparing it with other models. So the different other models is the deep belief network, stacked convolutional autoencoders, and the deep generative stochastic network. So there's some problems that came up when I started this project. In this, the code of this project, it uses PyLearn 2, and PyLearn 2 is deprecated. So I had to switch to PyTorch, uh, which after the switch to Python 3, and because I also wanted to see what changes might have occurred, as well as not wanting to use an old framework. So there's also different other missing information as well as deprecated libraries. For example, the number of epochs, specifically within the code, the code itself, it gave me the YAML file for the MNIST. It didn't have the number of epochs, but within another data set, the TFD Toronto face data set, it had 50 epochs. So I just took that 50 and assumed it was applied to MNIST as well, and took that. And the sigma value wasn't there in this data set. Uh, the sigma value is used for the kernel density estimation and or the Parson window log likelihood estimation. And I needed to essentially, what I assumed was that I try to tune the sigma value to see what gave me the best value in this project. Now, for the deprecated libraries that are used within the code itself was PyLearn 2 and Theano. Theano isn't used. I just used regular NumPy and just calculated everything. So it, that was fine. Okay. So the results that I want to reproduce, I want to specifically reproduce the MNIST results. The four different models are the DBN, stacked CAE, convolutional and deep GSN, as well as the adversarial nets. I couldn't manage to get the TFD dataset because it's Toronto-based dataset, and obviously that's very private data, so I would have to ask someone. It would be very difficult to get the dataset, so I just worked on trying to reproduce the MNIST values. So this is the pre-training epochs versus loss function for the DBM RBM layer, first layer. This is the second layer. I had two layers for my DBN, and this is the fine tuning. This I used 50 epochs as I stated in the beginning. The previous ones I used like 10 epochs to show the training loss. This is the partisan log likelihood for the DBN. And the best one I got was 413 plus or minus 1.59 with a sigma value of 0.147-ish. And as you can see, the higher it is, the better the log likelihood. So now what does the Parson window log likelihood mean? It is an estimation, or kernel density estimation. It is a non-parametric method for estimating continuous density functions. Stack CAE training curve. This is some of the output for stack CAE output. and this one had the best value of 13,1355.95 for the Poisson log likelihood. Deep GSN training curve, GSN output, log likelihood of 744.20 plus minus 78.81, sigma value of 0.088, and yeah, I'll explain the um compare the values at the very end to what it should be. So these are very much higher than what I originally what the original paper showed. So yeah. Now the GAN generator learning curve, as you can see, at after this point, it sort of stopped at loss of 10, and that signifies that it had like a gradient issue, um, where where I'll show. Let me go to the next graph, and then I can explain it better. This is the discriminator, which is 110. So it seems like the discriminator has overpowered the generator model, and thus it's learning to trivially separate the real versus fake data, essentially a mode collapse or a vanishing gradient problem. Now, there could be multiple reasons why this has happened. Um, uh, Let me first go to the Parson window, and it's negative 801, which shows it's not doing very well. All these are negative values. So multiple reasons why this could happen. The code itself has a very high learning rate, which of 0.1, which has confused me. Why would they use 0.1, which seems astronomically high as a learning rate? It also uses SGD instead of Atom, and Atom is more stable for GANs as well. This paper has been was created in 2014, so I'm not sure if it's because of that. That might be a reason why, but I obviously will have to look for why this has happened. But the GAN the grading issue within the GAN seems to be I think from those two reasons. Also, I would like to add there's no regularization for the discriminator at all, or no dropout. Dropout would also have helped a lot with the discriminator. Okay, so here are the results, and the results for my data show that DBN had a 413.55 compared to the 138 I expected. CAE had 1,355 compared to 121. GSN had a 744 and compared to 214. GAN had negative 801 compared to 225. Now, all these had a major increase, except for the GAN network, and that's because of the following reasons that I had listed before: the high learning rate, no sort of dropout or regularization within the discriminator that could help try to reduce that discriminator's overpowering the generator essentially, and the SGD instead of Atom. Uh, as for the reason why the other three have faced a major increase in results, is assuming that it didn't specifically mention how it gotten the sigma value, and if you take a closer look at uh, 1 second, here these sigma values, point 0.2, it shows like a 323. So if we assume sigma is zero point 0.2 or something, 323, it seems a lot closer, 369.86. That could be one reason. If you go all the way back as well, you can see further, have better understanding. And also, it could also, the also a huge reason is because I'm using a lot of the more latest frameworks, which has caused also a huge increase. So yeah, that's it. Uh, Thank you. Look forward to hearing any questions.